Well, hi, everybody. My name is Joe Rayo. I'm a broadcast meteorologist, and I'm also a guest lecturer and an associate at the American Museum of Natural History's Hayden Planetarium in New York. I also write a weekly column, Night Sky, for the online news service space.com, serve also as a contributing editor for Sky and Telescope magazine, and even provide astronomical information to that storied publication, The Farmer's Almanac. Right now, what we're going to do during these upcoming minutes is talk about a celestial event coming our way during the month of December, the Geminid meteor shower. Have you ever seen a shooting star? If you haven't, you're going to get a good chance to see more than just a few during the late night hours of Sunday night, December 13th, into the early hours of Monday, the 14th, and again, late Monday night, the 14th, into the morning hours of Tuesday, the 15th. This is one of the best, if not the best, meteor showers that you can view during the course of the year. And this video will serve as well, kind of a primer, if you will, to give you an idea of what to do, what to look for during this upcoming celestial event. It's a PowerPoint presentation, so what I'm going to have to do now is share my screen with all of you, which I'm going to attempt to do right now. And as I do that, what we're going to do is we're going to start right now at the beginning of my PowerPoint presentation and talk a little bit about the upcoming display, the meteor shower, which we all know as the Geminid shower. Okay, we'll start from the beginning here. Here we go. And I'm going to just close my shutter here to give you a better viewpoint of things. Now, some time ago, a friend of mine who is a physical science professor at one of the local colleges in the Hudson Valley gave a test. I think it was the final exam. And on that test, one of the questions was this: provide a definition for meteor in 25 words or less. And a young lady who was taking the test, I think she was right on the cusp of passing or failing the course, wrote the following down for the definition for a meteor. She wrote, "It's the flash of light caused by a falling meteorite. As it rushes through the air in flight, I hope to God this answer's right." Well, I don't know if she passed the test, but the professor gave her full credit on this particular question. That is indeed what a meteor is. It's caused by a piece of cosmic debris rushing rapidly through our atmosphere and causing it to be visible through friction with the atmosphere, an incandescent streak of light for a moment or two, giving the impression of a shooting star. So here's the date you should be putting a big circle on your calendar for: Sunday night, December 13th, and also perhaps Monday night, the 14th as well, because although the peak of the shower will be on the night of the 13th, you'll still see, I think, a fair number and some bright ones too on Monday night, the 14th, into the early hours of Tuesday, the 15th. Many of you are probably well acquainted with the meteor shower that comes our way during the summertime. In August, middle of August, the Perseid meteor shower. And if you've ever done a little bit of research or looked in some astronomy books, they say this is the best meteor shower of the year. Well, that was then. This is now. The Geminids have taken over as the best meteor shower of the year. And I was very happy and very pleased to write the cover story for the December issue of Sky and Telescope, the essential guide to astronomy. And if you are getting into astronomy, I strongly urge you to pick up that and maybe start a subscription with Sky and Tel. In any case, I wrote an article on the Geminid shower, and what we're going to present here is kind of like a video primer, a video version of the article for Sky and Tel. Now, I should point out this. When I was a very young boy, I got into astronomy when I was living in the Bronx, in the Bronx, next section of the Bronx, many years ago. But during my youth, while I was watching for meteors, my interest in the backyard of my home in the Bronx, my interest lay in the possibility, and you could call it Calvin and Hobbes logic, that a meteor might slam into my neighbor's yard, fresh and piping hot and ready for the laboratory. Now here we see the anatomy of a meteor. The flaming flash that we call a shooting star is not really what you might think, for the speeding missile itself is not what lights up the sky at all. It is the incandescence of the air ahead of it that couldn't get out of the way fast enough. The air ahead of so fast a thing gets packed into a white hot mass of compression, and it creates a big splash in the sky. As it enters our upper atmosphere at speeds as high as 40 miles per second. That is 100 times faster than the speed of a rifle bullet. Atmospheric friction releases the kinetic energy of the object in a short-lived flash of light, which we call a shooting star. Now, many of the meteors that manage to reach the Earth as geologic specimens called meteorites are still found cold, frozen, even freezing the ground around them, although their outside has been glazed by the heated air. As an analogy, imagine putting a blowtorch to a block of ice and you'll realize that the inside of the ice block could maintain its freezing or sub-freezing temperature while the outside melts away. Still, as a youngster, my mind was full of stories about a Mrs. Ann Hodges of Alabama who was napping on her sofa one day in November of 1954, and suddenly, through the roof of her farmhouse came a meteorite. It zipped through the roof of her farmhouse, bounced off a large wooden console radio, and ended up hitting her in the thigh. It was a 9-pounder and left her with contusions of the hip, as well as a pineapple-shaped bruise. More recently, in 1992, a 27-pound meteorite smashed through the trunk of the Chevy Malibu owned by a teenager, then 17-year-old Michelle Knapp of Peekskill, New York. Now, moments before, numerous residents of Pittsburgh, Philadelphia, Washington, D.C. all described a huge greenish fireball sailing across the nighttime sky. This was a Friday night, and its descent was captured on video by many high school football fans taping local games. Now, she looks kind of sad there, but don't feel too bad for Ms. Knapp. Now, she had purchased that used car for $300. But again, don't feel bad for her because she sold that meteorite, that 27-pound specimen, to a consortium of 3 collectors for a total of $50,000. And she sold the car, believe it or not, to Iris Lang. She's the wife of renowned meteor expert and collector and dealer Al Lang. She sold the car for $25,000. You talk about manna falling from heaven. $75,000, all thanks to that big hunk of celestial rock. Now, many people out there, when they hear that a meteor shower is on its way, are concerned that maybe they're going to get clunked by one of these stones. Is there any kind of danger in that happening? A letter in the early 80s, in advance of the Perseid meteor shower, landed on the desk of this gentleman, the former chief advisor, chief astronomer, I should say, of the Hayden Planetarium, Dr. Kenneth Franklin. Dr. Franklin was a man, I knew him for many, many years. He was one of my mentors in astronomy, and he was a man who was very tidy. He didn't use very many words when talking to you and describing a celestial event, either before you or in a letter. So a letter arrived on his desk from a Mr. Gary Mitchell asking about whether or not it'd be dangerous to watch the Perseid meteor shower. Is there a chance of getting hit by one of these cosmic pieces of celestial debris? Dr. Franklin wrote back, "Your fears, Mr. Mitchell, about being struck by a meteoroid during the upcoming Perseid shower are ungrounded. The streaks of light are caused by tiny particles, no bigger than pebbles or sand grains, that burn up high in our atmosphere long before they ever reach the ground. The only dangers of watching a meteor shower are getting drenched in dew and falling asleep. Sincerely yours." Well, you get the idea. So no problems and no worries and no danger if you're going to be going out looking for Geminid meteors in December. Now, whenever you hear about a meteor shower, I'm sure that many people think of something like this. This is not a meteor shower. This is a full-fledged meteor storm. This is the Belid meteor storm, and this happened in 1872. 2, maybe 3 times a century, you get to see something like this, where meteors fall not by the dozens or hundreds, but the thousands per hour. But you need very special circumstances. In this case, Comet Biela, that was the name of the comet, in 1843, split in 2 unexpectedly. In 1852, astronomers saw the last of it. That was the last time anybody saw it because it just vanished, disappeared. Many people felt that the comet had just completely broken up and completely faded away from view. But in 1872, on the night when the Earth was passing near to the orbit of that disintegrated comet, the pulverized remains of that comet impacted the Earth in the form of a dramatic display of shooting stars that you see here. This will not be the case on the night of the Geminid shower. I want to stress that right here and now. We also have the Leonid meteors They come around with a comet every 33 years, and every 33 years they put on, sometimes, a very spectacular display of meteors. They did that in 2001, and if you add 33 to 2001, that means maybe we'll get another chance at seeing a dramatic meteor display from the Leonids in the year 2034. But you don't have to wait that long to see meteors. We've got one coming with the Geminid shower this month. Now, some people have asked me, why do they call it a meteor shower if you're not going to see meteors falling from the sky like a sprinkler on a hose? And the reason is this: hundreds of years ago, when people were living without radio, without television, without newspapers, without magazines to entertain them, their one source of entertainment at night was the nighttime sky. They would go outside and look up. It was like an ancient form of connect the dots, except instead of connecting the dots, you connected the stars to form star patterns, or what we call constellations in the sky. The Big Bear and the Little Dog, Hercules, Hydra the sea snake. These were all made up by folks looking skyward and again connecting the dots or connecting the stars into various types of star patterns. And when they were watching the sky, let's say during the course of an hour or so, they would see a shooting star. They would see a meteor. And during the course of an hour, they might see 2 or 3 of those. However, there were some times during the year that more than just 2 or 3 were visible in the course of an hour's watch. Sometimes you would see 15 an hour, 30 an hour, 40, maybe even 60 shooting stars in the course of a single hour's watch. Well, my goodness, that's like a meteor shower, a shower of meteors as compared to what normally is visible. And that's why we call displays like this a meteor shower. So again, you're not expecting to see meteors pouring down out of the sky, but if you can manage to see, a fair number over the course of an hour, say, a few dozen, that's pretty good. However, the Geminids are not as famous and not as well known as the Perseids. Why is that? The Geminids are more prolific now. As I just noted, they are the best meteor shower of the year, yet everybody knows the Perseids. The Perseids are beloved. The Perseids are the most popular, but not the Geminids. Why? A couple of reasons. Number one, the Perseids come in August. It's easy to watch a meteor shower in August. All you have to do is throw on a light jacket or a sweater, stand outside, look up, and the skies are usually clear in the month of August. But in December, it's a whole different story. December can be a very tempestuous month in terms of weather, a very unsettled month, a very stormy month. And let me tell you, if there are a lot of clouds in your sky on the night of a shower, meteor shower, you're not going to see much of anything. You're not going to see any stars, and you're certainly not going to see any meteors. But even if the skies were clear, you would still have a problem, I think, and that is the cold temperatures. Now, this gentleman was somebody I did not get a chance to meet. He died in 1963. He's one of the old-time lecturers at the American Museum of Natural History's Hayden Planetarium. That is Henry Neely, who wrote a few books on stargazing and constellations. In fact, one of them is still an excellent guide, even though it's been long out of print. You might be able to find a copy on Amazon.com or BronzeandNoble.com. The name of the book is called A Primer for Stargazers. And he wrote about the stars and the constellations and other things, planets and meteor showers. And when he wrote about the Geminid meteor shower, he gave this piece of advice, which I would pass on to you now. Take the advice of a man whose teeth have chattered on many a winter's night. Wrap up more warmly than you think is necessary. So said Henry Neely in his book, A Primer for Stargazers. He's absolutely right, because December can be cold. And unlike August, when you're watching the Perseid shower and the temperatures are in the 50s or 60s, in December, you could have temperatures in the 30s, the 20s. I remember one year I watched the Geminids and the temperatures were close to 0 degrees. So you have to bundle up. That's the one thing that you need to do when you're watching a meteor shower in December. But, watching in December, you see a lot more, as opposed to August, when it tends to be rather humid and sometimes rather hazy. The nights in December are crisp and clean and transparent. So when you get a hold of a good, clear night in December, you tend to see a lot more stars. Although, again, you have to bundle up, and sometimes there's even snow on the ground. You have to be prepared. Now, I'm going to show you how not to watch a meteor shower. Let's say, well, this this person you're seeing on the screen now, he was just a few moments ago sitting in his living room watching TV, watching the 11 o'clock news. And on the 11 o'clock news, all of a sudden, in the middle of the news, one of the news anchors said, "Hey, do you know what's happening tonight? A meteor shower, the Geminid meteors. And you may see a few dozen shooting stars if you're watching carefully enough in the nighttime sky. Should be a really great celestial show." Well, my goodness, as soon as that person heard that, he turned off the television, stepped out of his brightly lit living room into his brightly lit foyer, threw on a light winter coat, and stepped outside expecting to see a great celestial display. He stepped out on his front stoop, looked skyward, and waited. He waited 2 or 3 minutes, saw nothing. Waited 5 or 6 minutes, saw nothing. Waited 8 or 9 minutes, saw nothing. And now it's getting pretty cold because, again, he's wearing a light winter coat. And after 10 minutes, he went back inside. And this pretty much sums up his look on his face about how he felt about all of this. And I'm sure what was going through his mind is, meteor shower? It was all media hype. I didn't see a blah, blah thing. And you know what? So many people who look for meteor showers, that is usually the case because they're doing it all wrong. What I just showed you is not the way to watch for a meteor shower. Number one, he stepped outside in a light winter coat, stepped outside after being in a bright living room and then a bright foyer. You step outside, look out in the dark, your eyes, the pupil of your eyes are likely to be very small. What you need to do to see the maximum amount of sky and stars and shooting stars is to stay out 15 or 20 minutes initially and let the pupils of your eyes widen. You have to get dark adapted. And the more you get dark adapted, the larger your pupils of your eyes, the more you're going to see of the sky and the stars. But again, you need to do, I don't know, 15, maybe 20 minutes outside in order for you to get fully dark adapted. So that's the first thing. You need to dark adapt your eyes to look up at the stars. Now, number two, this is probably the most important piece of equipment that you'll need to watch a meteor shower, not just the Geminids, but any meteor shower. A long lounge chair or a long beach chair. You probably use this during the summer. Where is it now? You probably stored it away in your basement or attic or your garage, because who needs a beach chair in December or January or during the cold winter months? But if you know where it is, break it out because you're going to need it to watch the meteor shower, the Geminids. You need that. Why? Let's say you go outside and you've dark adapted your eyes, and now you're seeing the sky and the stars, and hey, you just saw a meteor. And a few minutes later, there's another one and another. You're out there for an hour and a half, and finally you say, all right, that's enough, I'm going inside. I guarantee you, when you wake up the next morning, because you were standing outside, craning your neck up and looking around at the stars, I guarantee you the next morning, you're going to end up with a rather sore back or a stiff neck or sore shoulders. So in order to get the best out of watching the sky and the stars, use a long lounge chair like this. Use it, lie down on it, and that will allow you to not only see the stars in the sky, but take a lot of pressure off your shoulders and your neck while you're observing the stars. Now, we see our friend again, and now he's seeing what he went outside to see. He's bundled up not in a light winter coat, but in a heavier jacket or winter coat. He's got gloves on. You can't see them, but he's probably wearing a woolen pair of socks or insulated shoes to help his feet stay warm as well. He also has a companion with him, and that companion is a thermos jug filled with hot tea, hot cocoa, hot coffee. Don't drink alcohol. Don't hit the bottle if you're outside watching for meteors or watching for the nighttime sky. This is what you want to use. You want to stay warm inside with a bit of hot chocolate or hot tea or a hot coffee. And maybe you might want to carry a bag with cookies or maybe a sandwich or two to fill up. Now you're comfortable. Now you're in a position to enjoy the meteor shower. And you might want to ask perhaps some friends to join you as well. Maybe members of your family, or if you ask friends to come with you, remember now that we're in the midst of a pandemic or with the COVID-19 situation, remember to social distance, stay 6 feet apart. But it's always nice to have company when you're watching one of these things. The Geminids tend to produce let's say 2 or 3 meteors in the course of a minute's time, and then all of a sudden there are 3 or 4 minutes when there's nothing happening before the sky bears fruit again. And during that period, during that lull when nothing is happening, it's kind of nice to chat with friends or family and talk things over while you're gazing up and looking at the sky. Maybe even if you don't have friends with you, have a little bit of music playing in the background. It's great. So, meteor shower with a friend during the nights of the Geminid shower. Now, we call these the Geminids because they come from the constellation of Gemini. This is a view of the Perseid shower. In the summertime, you're looking up in the sky, you're looking toward the zigzag row of stars forming Cassiopeia, the queen. Below Cassiopeia is Perseus, right here. And from the northern part of Perseus, the meteors we call the Perseids are emanating or darting out from. And again, we call the meteors after the constellation they seem to be coming from with the suffix ID at the end. So in the summer, Perseus, Perseid meteors. During other times of the year, there's a meteor shower that comes from Orion the hunter. We call them Orionids. This one coming from Gemini are called the Geminids. But it's an optical illusion when you see meteors darting or fleeking out from a particular part in the sky, for the same reason that that this road, the center line, the lampposts, the trees are all not converging in one spot off in the distance. They are all in parallel to each other, so they never touch, although this illusion gives the impression that they eventually do touch down by the horizon. When we pass through a meteor stream out in space, looking up from here on the Earth, it appears that they're darting out or diverging from one spot of the sky. But again, they're all moving on parallel paths, but giving this illusion effect. And right here in the middle, the vanishing point is called the radiant. Here's an example of two Geminid meteors. Here's Orion the hunter. I'm sure many of you have seen Orion. If you haven't, on a winter's night, late at night, when you're looking over toward the south and southeast, you'll see Orion with his famous 3-star belt, 3 stars equally spaced and equally bright. And above and to the left of Orion are the twins, Gemini, Castor, and Pollux, the heads of the twin brothers. And these 2 meteors are Geminid meteors, because if you trace the streak backward, notice this one comes from the vicinity of Castor. This one, trace it back, comes from the vicinity of Pollux. So these 2 meteors are members of the Geminid meteor stream. In the evening, let's say you start looking for meteors at 6, 7, 8 o'clock, you can do that. But 3 things to note actually. Number one, the meteors early in the evening, if you're watching, let's say at 6, 7, 8 o'clock, the meteors will be coming from out of the eastern and northeastern sky. And they tend to move on very long paths. As you can see, this is what we call an Earth skimmer. It's skimming the top of the atmosphere, almost like when you skim a stone over a lake or a pond. And that's why it ends up making a long path. It can actually, in some cases, skim or move across from one part of the sky to the other. The other thing to notice is that in the evening, the meteors are generally not very bright. And number 3, they're moving relatively slow. Usually meteors streak across your line of sight within a matter of a couple of seconds. But in the evening, if you are happening to watch, especially before, let's say, 8 or 9 o'clock, you'll see meteors that are moving on paths that may actually hang up there for, 5 or even 10 seconds. And if you see one of these Earth grazers streak across the sky after and take like 5 or 10 seconds, that's quite a sight to see in the sky. But again, they move slow, and they're also, again, usually not very bright. But what happens after, let's say, 9 o'clock? By then, Gemini, the constellation from where the meteors appear, begin to climb higher in the sky. And as it gets higher, the meteors tend to begin to get faster and brighter. There you see the radiant of the meteors near the bright star Castor. And when we get to the after midnight hours, well, my goodness, at 2 o'clock in the morning, Gemini, if you're out there in your long lounge chair at 2 a.m., Gemini is directly over your head. And you say to yourself, well, is that where I look? Is that where I look to see the most meteors? No, you don't look directly over your head. Why? I told you that's the vanishing point. You want to look for meteors that are darting away from that vanishing point, and they'll be all over the sky by that time. So you look up into the sky in your lounge chair. Uh, you don't stare at any one place. Keep your eyes moving around, and pretty soon you'll see a streak in the sky. Trace the streak backward. A second one will come by. Trace that backward also until you see where they're coming from what pattern of stars. A third one will come by and intersect, hopefully in the same place as the first two did. Now this point of intersection is where the meteors are coming from. That is the radiant, and that is where we would find the emanation point of the Geminid meteors. Now, how many meteors will you see if you stay out, let's say after 10, 11 o'clock, midnight, or into the wee hours of the morning on Sunday night? And, well, on Sunday night, how many would you see? If you check out, the hourly rate given for the Geminids is 120 meters per hour. Oh boy, you say, great, 120 an hour. I can hardly, but you're not going to see 120 an hour unless you happen to be in a place that is very dark. You're seeing on the screen right now an example of light pollution. The I-95 corridor from Washington and Baltimore to Philadelphia. Wilmington, Delaware is here. Here's New York and Long Island and parts of the lower Hudson Valley, up to Hartford, Connecticut, Providence, Rhode Island, Boston. Right along the I-95 corridor, it is a continuous band of bright lights. If you are going to be anywhere in this area, if you live anywhere in these areas where it's very, very bright, I can't promise you're going to see a whole heck of a lot of meteors. You probably will see, even on the peak night, 5, maybe 10 per hour. The key here is you have to get away from the bright lights. The further away you get from the light pollution, the darker your skies, the more stars you'll see, the more meteors you'll see. At the Hayden Planetarium, we often get a lot of complaints from people in the aftermath of a shower. People complain to us. They say, I heard on the radio I was going to see 60 meteors an hour. I was outside. I saw maybe 5. I said, well, where were you watching? I said, I was watching from Forest Hills in Queens, or I was watching from Lafayette Avenue in the Bronx, or downtown Newark, New Jersey. Well, I tell them, of course you're not going to see that many. It's because of the lights. The more lights there are, the more light pollution there are, the lower the count of meteors. Where can you go to see a lot of meteors? Go as far away as possible. But even 50 miles north of New York City, I live 50 miles north of New York, and I can see, looking toward the south, toward New York, I can see a bright glow in the sky. That's New York City. 50 miles away, and I can still see the effects of light pollution of New York. You really have to get far out. I mean, if you can get up to the Catskills, or maybe even the Poconos, or especially the Adirondacks or the Berkshires, someplace where it's really dark, far away from light pollution, that's when the count of meteors that you will see will go up to 50, 60, maybe even 100 per hour. Again, the darker the sky, the more meteors you'll see, and also the more sky you see, the more meteors you'll see. If you live in an area that has a lot of trees around you, or tall buildings or houses, you're not going to see all that much, because those will be obstructions to visibility, obstructions to possibly seeing a meteor. If a meteor happens to fall behind a house or a tree, you're not going to see it. So you need to look in a place where there's as much of the sky visible as possible. I mentioned earlier about how if you look before midnight, you're likely to see meteors, but they'll be slow moving and they'll be not so bright. And the reason is this. This diagram shows you the orbit of the Earth. The Earth is moving in this diagram from right to left. The Earth is moving around the sun at 66,000 miles an hour, 18.5 miles per second. So here we are moving in our orbit. The Earth is turning on its axis, again in this diagram, moving from right to left or counterclockwise. So in the evening, you're here on this side of the Earth. Make believe you're on a train. Make believe this is the caboose, and over here is the front of the train, the engine, right? So at 6, 7, 8 o'clock in the evening, you're over here. If you're going to see any meteors, the meteors must be moving as fast or faster than the Earth in order to run into our atmosphere, in order to catch up with the Earth and move through the atmosphere. That's why meteors that are seen before midnight tend to move somewhat more sluggishly. And because they're moving slower, they're not quite as bright. and you don't see as many. You might see only 2 or 3 in the course of an hour's watch without a meteor shower. With the Geminids around, you will probably see a bit more, but again, slow, faint meteors. Now, let's wait until after midnight. Let's wait until 2, 3, 4 in the morning before sunrise. Now you're on the front of the side of the Earth that's moving along in its orbit. Now, even a meteor that is not moving particularly fast is going to seem fast because you're running right into it. And if there are any meteors out there that happens to be running contrary to the orbit of the Earth, moving directly toward the Earth, clashing or hitting the Earth from the opposite direction, that's really going to appear very fast and bright and really will stand out. So that's why you tend to see brighter meteors, faster meteors after midnight, and more meteors as well. You tend to see a lot more meteors when you're running into them after midnight, as opposed to before midnight, when again, the only ones you'll see are the ones that are able to keep pace or catch up with the Earth as we move around in our orbit in space. This is a classic example of what we call a fireball meteor, especially after midnight. You have an opportunity to see meteors, brilliant meteors. I mean, this particular one, photographed by a person who caught it dropping straight out of the Geminid radiant, past our old friend Orion and the 3-star belt, and look how bright it eventually got. This meteor, well, to give you an idea, over here is the brightest star in the sky, Sirius, the dog star. This meteor must have appeared many, many times brighter than Sirius, quite possibly even brighter than Venus. So you can possibly see an outstandingly bright meteor or two, a fireball, especially after midnight, late Sunday night or early Monday morning, and again, late Monday night into early Tuesday morning with the Geminid shower. And some of these meteors, some of these particles have been out in space deathly cold, hundreds of degrees below zero, and suddenly in a heartbeat, it heats up due to friction in the atmosphere. And sometimes these meteors break up, fragment. And when they do, they suddenly appear with a burst, like a strobe or a flash bulb. We call this an exploding meteor or a bolide. And they can be quite spectacular as well. I saw a bolide once, and it left a trail of incandescence. And then toward the end, it popped, just like a flash bulb. And in doing so, it lit up the whole area around me for about a second or two. Now, initially, the meteor appeared, or the trail that it left behind appeared straight and true, and it hung up there for about 10 or 15 seconds. I was able to keep it in view by looking at it through binoculars. That's a good thing to have also, along with your lounge chair. Have a pair of binoculars, not to try and catch one through the binoculars as it streaks across the sky. You'll never be able to do that. But if a meteor flashes through the sky, leaves a persistent incandescent or vapor trail behind it, pops like a flashbulb, look at it with binoculars. Look at the trail through binoculars. The upper level winds at 40 to 80 miles up where these meteors are appearing, that's where they are, 40 to 80 miles above your head. At that altitude, the high level winds will take that incandescent trail, that straight trail, and distort it into a corkscrew, or maybe bend it into a semicircle, and you'll be able to keep it in view through binoculars for a much longer time than if you were watching with your own 2 eyes. Geminids are also colorful. Oh yeah, 90% or so are yellow-white, but the other 10% can be red, can be orange. I once saw a green Geminid meteor. You don't see night sky objects that are a color green. Sometimes the Geminid will flash on through that's particularly bright, and they could appear green or even blue. But because they move more slowly in the evening, Geminids tend to be more colorful, at least it's said to be more colorful, before midnight. They come from an asteroid, the Geminids do, an asteroid by the name of Phaeton, discovered in 1983. It moves around the sun in an orbit that takes 2 years to move around the sun. And at its closest, the asteroid comes even closer to the sun than Mercury. Mercury is 36 million miles from the sun. We're 93 million miles. The asteroid can come within 14 million miles of the sun. And when it gets that close, the asteroid glows an orange or reddish color. And the asteroid begins to, at that extreme heat, 1,500 degrees, enough to melt aluminum. The rocks begin to crack. Crevices begin to appear. Fissures begin to appear. And what happens? Out of those cracks and crevices and fissures come tiny little particles, which stream out behind the asteroid out into space. This truly when you look at it, because a lot of meteor showers come from comets, but the Geminid meteors are one of the few that come from an asteroid. So it's truly a rock shower. Here's a view of the asteroid when it was close to the sun. The asteroid is here, and these contours are indicating the bands or uh, ribbons, if you will, of material that are being released by the asteroid as it's passing close to the sun. And those trails, that trail of debris, we run through that trail of cosmic debris, that river of rubble, every year in December, and that creates the spectacle of the Geminid meteors. Now, unlike a number of other meteor showers whose historical records span centuries or even millennia, the first definitive appearance of the Geminids dates back to just 1862. Before 1862, there was no Geminid meteor shower. Then all of a sudden, a few started to appear in 1862, and they have improved every year since then. And in fact, by the late 1980s, they were equal to the Perseid meteor shower. Now they're much better because we're getting closer and closer to the center of the swarm of the meteors. I did a study in Sky and Telescope magazine. You can read about that. The Geminid stream is associated again with that asteroid Phaeton. Before 1862, the orbit of Phaeton and the Earth were widely separated, and we couldn't see anything because the asteroid orbit was too far from our orbit. But in the years since, we've been getting closer to the orbit, closer to the asteroid. Now we're pretty much right in the thick of things. And by 2080, the asteroid orbit and the Earth's orbit will pretty much coincide. But then after 2080, well, we're going to be moving away from the asteroid orbit again. And by 2300, well, goodbye Geminids. After that, the beginning of the 24th century, I think we'll be pretty well done with the Geminid shower. So no matter what the future holds, I think we should consider ourselves fortunate to be living at a time when we can enjoy such a wonderful celestial pyrotechnic display each December. So think of the Geminids as nature's free holiday gift, one worth braving cold temperatures to receive. And if you like this presentation on the Geminid meteors, then please consider subscribing to my channel, my YouTube channel, Joe Rayo Weather, on Indeed YouTube. And on my YouTube channel, we talk about a number of things. We talk about upcoming celestial events like this meteor shower. We'll also be talking about things like the Great Conjunction of Jupiter and Saturn, which will be happening on December 21st. And also when we have special meteorological events like potential storms that might be affecting parts of the Northeast or the New York City metropolitan area. I'll be talking about stuff like that as well. Again, on Joe Rayo Weather, please subscribe on YouTube. It does not cost anything. And I really would appreciate if you did subscribe. I'm going to stop sharing my screen right now. Here I am back again. And I want to thank all of you for watching this primer on the Geminid shower. I hope that you've learned something. I hope that you get a chance to see a good number of shooting stars with the Geminid stream coming up again late on Sunday night into Monday morning. Maybe not quite as many, but lots of bright ones expected again for Monday night into early Tuesday morning, the Geminid meteor stream. Again, thank you very much. If you have a chance, subscribe to my YouTube channel. And again, thank you. Stay safe out there. And this is Joe Rayo on YouTube. Have a good one, and we'll see you soon.